Hi, let's go. Thank you a lot for coming in. I hope we're going to do a great session today. And let's go. Maybe if at some point I will look every 10 minutes, I think, if you have something to add. To that, I think as you worked on the RenéPay, maybe there may be a lot of things that you know that I don't know on the routing on what we are going to do today. So please correct me or ask any question. Let's go. So this is the second part of a series of lives on the videos on the Room that on the build on L2 about Vault 11 invoices. So I really want to understand how it is implemented and also understand the protocol. So we do both those things, and that means that we each time we try to understand a little bit more the protocol and also a little bit more of a Core Lightning implementation and how we can find information in it, either to open issues if we need to open issues, so how to look for the logs, or how to fix some issues, and how to modify the code to make it as we want it to make it. So it's open source, so we can obviously change it and compile it. So last time, just to see quickly what we did last time is to see how command in Core Lightning, so in Lightning D, not in plugins, are defined. How do we define them? And we wrote 3 of them. And this is interesting for 2 reasons. I think that the biggest reason is to let us the possibility to understand many parts of code lightning. So if we know how commands are defined, this make a link, a direct link from the command line to the piece of the code where everything starts. If we don't look at how that command, how the JSON RPC interface is done, but just we get some the arguments and we do those stuff. So first thing, and this help us. Why we do that is because we want to understand the command invoice, and not only the part of generating the Bolt invoice encoding in Bake32, but everything around. And the other part that can be useful at some point is to be able to write our own command. But I think this will happen less often than the first one. And today, we still are not going to look at the Bake32 encoding of the information that there is in the Bolt 11 invoice, and we're going to look still at the data that we want. So this, to me, there are two different parts of the data that we want to put in a representation with Bake32 encoding. So there are two parts of the data: how it is managed by Code Lightning, and then how do we represent it with Bake32 and specified by the Bolt 11 protocol, part of the protocol. So today I want to look, and we are going to look together at the routing information, routing hints that can be added in the Bolt 11 invoice. So we are going to look at that, and we are going to try to start from the invoice command in the code and look around, and really I will do it because there are some parts that I still don't understand, but we will try to look to where to find information, and I will do it the same way as I do regularly when I try to find the information. And as I try with each live or videos to have something that we can reproduce and do. So one of the things today that I would like to do is to see how we can use the function log debug or log info to log some information. So as when we run Lightning D, this is a daemon, and we don't have access to this standard output. So to get some information inside what's going on, so we can use a debugger GDB if we want. So in the documentation, this is done at this is written how to do that. But there's another way is to print stuff in the log, and this is already done for many reasons in the source code, and we can learn from that how to do that. So for instance, there's a function that is really important to do that job, and also to produce output of a JSON command, which is the function type to string, and we are going to play with those functions a little bit in one of the functions that is doesn't do the calculation of the roots, but at that time we are going to see that. So I hope this is okay, and we are now that we want what before defining the root field. See, yes, first the root field. So we go into so I have cloned in my computer the Bolt 11 document, and in the where to look for. So a Bolt 11 invoice is separated with two parts. and the separation is the last one in that string. First part is human readable, so we just know that there is that part, and then there are the data part where we can put some stuff. So here we have the data part, and we have first. It's broken into 3 pieces, and the first one is the time stamp, and the other part are tagged parts. So we are going to look at the tagged part, one of which is, so we can see here the tag field. So the tag field are represented. This is a representation, we talk about it, but this is not the focus of today. But just when we look at the multi-event invoice, at some point when we pass the time stamp, we are going to have a type. So for us, the type that we want is R. Then 10 bits for the length of the data that we put after. And then we read, when we have a parser of the invoice, we read that data, and we find another type, another length, the data, and we repeat. So there are some tag fields that are required, and one which is not required, but we are interested in today. Why? So why I wanted to start with that one, and not starting with, for instance, the required one, and starting with the human readable part and all those things. This is because when we run the invoice command at the command line, for instance, we get something on that command line. We've seen last time. We're going to look at it right now too. Before doing everything at the end, there a piece of the code which is about the root ins. So if we look really, if we are looking, I start by the invoice command. I go to the code and I try to understand and to dig into those things. To me, it's natural to say, okay, let's see that, and we are going to see that as we need to call a command defined in a plugin, this is the moment to see how it is done inside the code if we need at some point to call some command innately. So routing ints are maybe it's called extra routing. So this is a data that we can add to help the payer to take some decision about that. So it can be, if I'm not wrong, also private channel, or not on a channel that are not private. So that we don't specify them when we create the invoice. We have Lightning D that calculate one or more for us. And we see here this as the information that we need about that channel. So the pip key, the short channel ID, fee base, CLTV, so all those information. So let's now that this is that data that we want, but we don't care about how it is transformed into the beg32. We want to see where Lightning D get that data, and when does he get that data. So we go back to or not. So we want the root field. Let's see for this. So the invoice command. But we were talking about, this is really that one. So L1 CLI is for the Lightning CLIs with running on wake test. We pass the invoice and we get those fields. Because I try to, if you were not or you haven't seen the previous episode, so we look a little bit at how commands are defined, and here we have a typical example with JSON get info. So this is for the command get info. We have 3 things to do, which is to define some function that return a command result. Then we define a JSON command, and inside we specify the JSON getInfo. So to say, when I call getInfo, use JSON getInfo function to do that. And the autodata that line is just to say, okay, so now make that register that command in the JSON RPC interface. So this is how it's done. And to stay near of what we want, we see that what we want to do is to understand the invoice command. So we did a my invoice command that is not exactly the invoice command, but looks like that one. So we jump into that, and we can see. So I just narrow the part inside. So we see we define something, a command that shows up. In this one, we use it, and we define, we make it available everywhere with autodata. And what we have inside, this is just the thing. So we have some parameter. This is what we expect when we run a command. So we have some parameters. So we take some parameters, and then we start a JSON stream that we call a response, and we are going to put some information in it. This is what we see in the output. So in that case, we will add an ampersand, and if we have a description, we will also add that description, and at the end, we return a command success, and this is what we get. Okay, so this is in the case, in the simple case, when we have no things to do. But in the case, so now we go into the Lightning repository. Oops, no, sorry, so it's not this one. Like this, Lightning. So let me show you. So this is my directory. So we have the node on the CLN scratch. So these are my scratch, and the Lightning repository. So now we go in Lightning. We want the file invoice. Sorry, so invoice, and we want it in Lightning D. We jump into it, and as before I was visiting that file, so we are directly in the JSON invoice command. But if we narrow everything, we see that this is that file with all the function in the invoice files. And let's maybe narrow to only the JSON invoice. So here we have a bunch of parameters. Okay, so this is exactly what we see if we put this below. Okay, so we see we have some parameter that we pass. So the first one are required, and this is what we have here. We're not going to spend too much time here, but just to say that this is always the same thing, and we need to we just have to do some of the things the same way. So then we go there at the bottom. At some point, we don't care about that today, but we calculate, we compute our pre-image, important things, and at that point, we see we have an info. This is a struct that contains the information about the invoice we are creating right now. And in B11, we create a new bulk 11. This is where we are going to put as much information as we need to create the Bake32 bulk 11 invoice at the end to encode that thing. And we see we have some information that we just calculated there. But there's one that we need to calculate, which is B11, and we want the root. So we have something here that. So honestly, I didn't look at every aspect of how the roots are calculated. So I'm not sure exactly what's done here, but we're sure that this is the thing that we want to determine and compute here. And we see when we go at the end of the command, we are not returning comments. Let's see to the note. In the note, we see, so my invoice, we have a really simple case, and we return command success at the end. So this is really when it's done, command success, and the Lightning B return to the client the answer. Here we have the command still pending, and why? Because the command will be the command. Sorry, the command success will be done somewhere else. Where is this somewhere else? So this is why I wanted, before looking at the beg32 encoding, looking at, okay, now we have to find when it is returned, and this is done by another command. But before, what we see is that to get the roots, so the int roots, to calculate the int roots, we use the command list incoming. So we see that command, which is here. I will check if there is any question. So is there any question, or I continue? If there is no question, I wait and drink a little bit. Okay, so, okay, perfect. So we continue. And at some point we will write something, because if we, to me, when we read too much, at some point we are just lost. So we were going to jump into the terminal, do some stuff, and it will be better. So now we need the root info. So what we do here is that we are creating a request that we call a rec. And this is a JSON request that then we use plugin request send to send that request. Okay, so we send that request, and that request, by the information that we have, the parameter here, we see that we are calling the command list incoming. So this will find the right plugin. So this is this comes from the plugin topology. And this will return the roots. Now, how it is? It returns the inbound, the channel. Yes, yes, the channel with inbound, I think, to us. So with that, we want to do something, and in that case, this is the callback function that we are going to use. So list incoming done. This is when we receive so the roots from not the roots, but the incoming channel from a list incoming from the topology plugin. We apply it the list incoming done function, and that one will be one of the parameters with all the information that we have so far, and that we are going to modify and use, and it will be modified by list incoming. So let's jump into list incoming done. This is in the same file, so you can see in the bottom line the file name in the Lightning repository, so Lightning D invoice. And here we have the list incoming done. So we can look at that and say, okay. So the info, okay, so this is the invoice info that has all the information that we want. And now what we are going to do is we want to modify the info B11 roots. So this is our goal. So we take the buffer and the token. So this is the way the Lightning repository uses a Jasmine library to deal with JSON object. This is the way it is done. So the buffer with the tokens, and we get to something interesting. Okay, so add root ints. So at some point, this is the function that we are going to look at. So with the buffer on the token, which is the incoming channel from a list incoming that we get, on the info, we are going to calculate some route that we return. And if there is no error, that means that we have modified info. And at the end, we use that info to do an invoice complete. So before we go to add route int, let me just go to jump into the function invoice complete to see. I want to go till the moment where we have command complete. So let me see this. This is now command success. So we want to see when that stops. I don't know if you want, but I think yes, you want. I want to know that. This is when I'm looking. I want to say when it's done. Okay, so at some point we see that we are returning something to the user. So invoice command in the same files. Invoice complete. Sorry. Okay, so we have it right now. Okay, we continue the info. We see that here at some point we do the encoding. This is something that we need to do it at some point. Okay, so with all those information that we had before. I'm sorry now. Sorry. Now, okay. Sorry. Not all the information so it's not incorrect what I said, but it's not the info. This first part is a TAL object from which. So this is the library that is used in Lightning in CLN to do memory management, and so anyway how it works. One, because I quite don't know, but this is a tree allocation, and when we allocate something, we need to allocate it from something else, so a TAL type, so that when this is destroyed, every leaf and branch of the tree will also be freed. But this is that part, and no. The information is in that part, info B11. So this is with that we do the encoding. And let's go a little. We go down, and now we don't look at how it's done right now, but we see, okay, we construct the JSON stream success that we are going to return. And if we look at the first one, payment at, expire at, bolt 11, bolt 11, payment secret, create index. So let's look at the node and go to our first this example, and we see that when we call the invoice, we receive that object. And to me, it's alleviating to see where this is written. So this is at that point that the information is written on the stream, and we need. So we have some information, and we go back to command success. Okay. We didn't look at root. Add root int so far. I don't remember the name, but we go back to this. But what we've seen is how. So we go back, and I think we can go back. Okay. So we are in a JSON invoice, and we've seen at the end to follow the data. There's something that says follow the money, and we are going to follow the function definition. So we are almost done. We send list incoming to the plugin topology. When we get the answer, the response, we apply it list incoming done, and then in list incoming done, we do add a root int. Sorry, I want the name exactly. It's add root int. Okay, this is the name. And then we do invoice complete, and in invoice complete, we end with command complete, and we're done. Okay, cool. So this is for the structure of the thing and when add root ints happen. We are going to look at root ints, but first we go and we start the rake-test networks with two nodes. We are going to generate invoice, decode the invoice with the function decode. We are going to see that we with one channel we have no root. Then we are going to look at the log and see some information in the log. Then we are going to find another channel, and we see that when we have two channels, this gives us a root int in the multi-level invoice. So we are going to decode, and then we are going to use. So this is what I was saying to you. I really want today, at least once, that we look at the logging that can be done inside the Emacs, because this is really that will give you the power to find information by yourself and by myself too when the live is done. Let's go back to the terminal. So we are at the top, and I will just look. Okay, so question. List incoming is not in the API reference. Yes, it is. Yes, okay. Yes, this is from a plugin, and I think maybe it's just that we are. I tried to look for it, but I think that there is no main page for this. Is just why we don't find him. But we so before we continue, let's look for that one. So first, if we look in the doc. And for invoice, for instance, we would have Lightning invoice something, which is a main page, and I think that list incoming doesn't have one. So we have a Booker list income. So maybe it would be great to maybe add a PR to add some information for that. But maybe it's not there because it's just used by the internals of Lightning D in general, but I'm not sure. But what we can see, it's really because there's no main page that we don't find it. But if we want so this, if we want to look for that, so we are going to do a grep of that. So we look for list incoming, and we see this is in the plugin topology. And we have it here. So there is a description. List as a channels incoming from our direct peers is used by invoice code to select peer root int. So this is done in the topology.c file in the plugin. So here we have get root, list channel, list node, and list incoming. So maybe it's just something that have been forgotten. I'm not sure. So I'm not lost, but okay. Let's continue and do this. Because this is the part, or maybe things don't work because we now are writing stuff. Before it was really cool. I love reading code, so it was because there's almost never any mistakes when we read the code. So we use that script in core lightning to start two nodes. So we start two nodes running on reg test, and this should work. And we then have access to them with L1-CLI and L2-CLI. Did we found something? No, we don't find anything, and we are just going to L1 CLI, and we are going to create an invoice. So invoice 10,000 millisat, and we are going to do this like that. So label 1, so we can follow description 1. So we have 1, and what we want to do is to decode that bolt 11. So L1 CLI decode, and we decode this, and we see this is all the information that at some point core lightning computed or got from somewhere, and then it is put into that fix. But we see there we could have another feed with the root int, but it won't work right now because anyway we don't have any channel. But maybe we can look at the log of the node. Sorry, I used the node 2. I used the node 1. I wanted to use the node 2. Let's do it again. CLI invoice. I use the node 2 because the font command is already done to font from the node L1 to the node L2. So 10, we have that. So we still can do label 1 and description 1. We have that, and let's look at the log L2. This is where the node L2 is defined. We go into the load, and we can look for root int. So I know that because I look at the code before, so I know that in the add root int function that we are going to look at, there are those log stuff. So we see this is done there, and we have the root int, and that the JSON. So we see that JSON is what we get by calling list incoming. So what we've seen before, at some point in at root int, we call list we get that result, and we work with it, and we see incoming. We have no channel at the end. So this is what we have on the. We can see that, and we see no public channel using private channel, but we don't have private channel, so we don't specify private channel, so nothing happens. Let's go into the terminal and do L2 CLI list incoming. Okay, so this is exactly what we have in the thing. So maybe what we can do. Okay, so yes, we are going to now. First, we are going to fund the channel with a fund node, and just that should fund from the node L1 to the node L2. Okay, so we do that, and then we jump into the piece of code where we see that we get the list incoming, and we log some stuff, and we take some decision, and at the end, with that creation, the final result root int is calculated by another function, but the information comes from a list incoming. So we have that. So now we should have list incoming. We have a new channel. church channel ID 10310. If we create an invoice with only one channel, so I must say that I don't know exactly how it is computed. So I can say, why is it is computed that way? But I will show you where it is done if you want to go further. We have the structure on all the pieces, but not exactly. If we only have one, this won't be computed, and we can see that by creating another invoice with the node L2, and we do that, and we are going to decode again L2 CLI decode that invoice. We get that, and we still don't have root ints. So as we are doing a live about root ints, it would be great to have some. So let's manually add fund a channel. So okay, so fund channel. These are the commands to use to do that. L2 CLI. We want the node ID. So ID -r. So we have the node ID, and then we found from that ID. Okay, so L1 CLI fund channel. That ID, and maybe we can put 100,000 sat, I think. Okay, so now as we're running on the reg test, we need to mine a block. So Bitcoin CLI, Bitcoin on reg test with the default wallet that we've created when we start the thing. So we get a new address, and then we generate to address. So we mine one block to that address. And now we have to wait a little bit. I don't know exactly how long it is. Sorry, we just closed the log file, because if not, in the bottom I have some pop-ups to say that the files have been reverted with the changes. So now in list incoming, we see that we have twice a channel that enters, the second one with that short channel ID. And now if we create again an invoice, we are going, I hope if I understand correctly how it works. So now we should see CLI decode, and we decode that, and we have the roots here. Cool, no? So cool. Just that we have it, but now we have to go into the code to see where this happened. But it picked the second channel. Okay, let me just, if there is a question now, since there is no question. So if any question, write it down. We continue. So we have the roots. Now let's go back to the log again. So we go back to the log. We are where we were before, and let's continue on the root int. So we see that we have two more lines with root int normal, because that one. So, it's to see everything. Can I do something like that? Maybe I will try something. Maybe I can narrow. Okay, so I narrow, and we see so that line where we have the incoming list incoming command happening, and we get this is what we got at the command line. So list incoming, and we just have one function, and there we see that this is a dead end. Not sure what does that mean exactly, but let's continue the last root int with the last one, and we see that at that time we add the two channel. So we see the channel short channel ID, and we see in the JSON this one. So so we narrow, and we are going to see again in the incoming. Now we have two channel with incoming with inbound liquidity, if we can say that like that, to our nodes. So from those two one of the function in Lightning D will take care to choose the right one and do the right thing. I think also to okay, let's continue. So now this is cool, and we go back into the invoice.c. We were at that point, okay? List incoming underscore done. This is a callback function that do something with the list incoming. So what we see here, we have it here with this. Okay, so with that things, something is done, but this is list incoming done that do that. We've seen how to complete. We do that because we've modified the info struct with the right information. And now we go to add root hints. Okay, so this is here also. Up. Okay, we are at this one. Okay, so if I remember correctly, okay, so this is a game of it's not follow the money, it's follow the function definition. So list incoming done the callback function, add root hints that will modify the info here, and specifically what we want to modify, this is the root field of a B11 struct. And this is then finally we are here with the candidate and root int candidate, and we are going to when we jump to that function definition, we will see the log where the log were in the log that we've seen just before. Okay, and just we see the candidate is an array with the right with the right channels with incoming liquidity. And what we do at the end is if there are many details that need to be done to take into account everything and many things that I don't understand, or I don't even know what it is so far. But I hope someday I will know. But what we do, if something works well, this happened at that point. So we see that we set the root by selecting selecting the inbound channel with. So this is what we with all the information that we have. So we can see select in channel. So we this is the one we are not going to look at it, but we just jump to see what it does, because there, when we pass the root X candidate, so the candidate that we are going to see how they are calculated, this is the decision that is taken to build really what goes into the root ints that we've seen in the terminal. So from the array of incoming channel, find a suitable one with the amount you need, and there are some criteria. So the channel pitch is known, and state channel normally is online, and channel spare capacity to pay us is sufficient. And there's something here which is to make harder to. Okay, so there is some sampling on random stuff done here. So to choose one channel from the set of suitable channel. Okay, so this is done at that point. Let's go back here. So in select in channel. So this is where when we set the root. The root have been selected. They are set into the roots. The root field of B11, and what we've seen at the end is that this is used to encode that part. The error that we've seen at beginning, here's encoding that we've seen in the Bolt 11 protocol definition. Okay. Let me brief a little bit and see where we are. I hope you're still with me, Eduardo. If something is not clear, maybe tell me, and I can make it clearer right now. And if not, it's not that we are almost done, but we are going to log some stuff. Okay, cool. So we continue. We go a little bit. Okay, so we are in add root int, which is called in the callback function. From when we we receive list incoming information, and that information from list incoming is here, buffer and token and the tokes for the token, and there here those things is what we are going to set also, and we pass. In the info and the command, we have LD, which is the state, the lightning D. This is the global state of lightning D. We have that, and we go to root it int candidate. So we are, we can see we are no longer in invoice.c files. We are in the root int files that contain only two functions. We can see that there are the function, this one, and a root int candidate. Okay. So to not make everything longer than it needs, we are just going to look at the debugs. So, remember, just a minute, because I'm not looking at, I'm not doing it by earth, or how to say, by memory, but I just follow the function definition. I think it's clearer and more honest it's less error prone with my memory. So at the end, okay, so we return the candidates, and the candidates need to be determined at some point. And this is done. Okay, we have the candidates. We look through some things, through an array. And in that array, we are going to see that this is what we do. We set the candidate's information. And now what we can do before looking at that, we can go there. And I said at the beginning that we want to compile at least twice and see what we can do. So this is that line. We go to the log that produce that line in the log root ints, and we see what we've put after the JSON. So I found that this one is, to me, it's really super great to see, because there are many things in Lightning D that it's done by so we by talking to the JSON API interface. So what we get is a JSON object via in the form of the Jasmine library. So generally we have a buffer on the JSON Jasmine talk type, and we can do stuff with it. But something that is really cool is to be able to just throw in the log the JSON object. So this is done with log debug. So let's unpack a little bit what happened here, and we're just going to maybe change the log debug and see if we can put another, which is log info. That part. So the first element is the logger. So we have access to Lightning directories, and when we have access to it, we can log with that one. So we pass it. We need a logger. This is the format string, and in that format string, we pass it. How it is called? This one is not the. This is the precision. It's not called the precision. I don't remember the name, but with those two one, we take the length of the following string, and we get them with JSON token full length and that one. So we pass it the buffer and the token, and we see that in many functions. This is what we have, and we can use it like that. We take everything. Log debug. So we jump to its definition. So this is a macro, and we see that this is not the only macro that we have that we can use to log stuff. So we also have log debug, log info, log unusual, and log broken, and those log are specific to the functions that we use in Lightning D. If we are in another places, we need to use another function which is called status debug. So it's in the documentation. But when we are dealing with Lightning D, we can use those one. And let's just copy that one. We copy it, and we change debug by info, and we are going to see now two lines that change. So we compile again. Sorry, we didn't compile before, so it might take a little bit of time to compile everything. And we can see at the top that I'm running make -J4 because I have 4 CPUs. Let's go back to the terminal and just check one thing. What do I want to check? Yes, as we are compiling, I must tell how I configure. So I run configure, and it was disable rest. So this is how I set the variable if you want to reproduce. Not done yet. And let's go back to the note. Okay, so we are almost just, I think that 10 to 15 minutes more to to see the other things. So the log debug, we are using the log info right now. Doesn't talk full length and doesn't talk full. Really helpful to know about those one. I didn't know about those one before looking at root int, but I thought I have to use a type to string to have all the things separately. But it's really cool to be able to do that that way. The compilation done. No, not done yet, and then. We're looking at type toString, which is also really important. We go back to the terminal. As we know, CLI, we know that we need to stop because we are recompiling, but we need to restart the node, at least this one, with how to say, with the new compiled version of Lightning D. So the alias was this one, and we are going to change it, alias for Lightning CLI, and this is Lightning D, and we call it start, so that we can stop and start at will. So Lightning CLI stop, we stop that node. L2 CLI, no, start. Before we start, let's see if the compilation is done. So everything compiled correctly. So we start that node. Sorry. I wanted to do an alias, but maybe we want to add daemon. So start daemon. So it started. We generate a new invoice, level 4, description 4. We have that, and now let's go back to the log, because what we are doing right now is looking at understanding how we can log stuff. So now we have two lines of root int. So we have the new one that we use, and we can see that as we used info, log info, this tells us the level of log. Also note that in the config that we use, the log level is debug. So this is why we are seeing everything, all the debug line in the code. If we put info only, all this information go away. So let's go back to say add root. Okay, root int. So we've done that thing with the log, and let's see another one, which is okay. Sorry, what we were doing in the root. Yes, because I say yes. Let's see how to do the log. So we remove that one that we no longer need, but we lost what we were doing, which is to create the candidates, which is an array of the channel with inbound liquidity to the node L2. So what we do is blah blah blah. At that point, so we get the result from list incoming. If everything goes well, then we get the array, which is the value of the feed incoming from a list incoming that we've seen. Okay, so from that array, what we are going to do is to loop in that array and create the candidate the way it should be. So that line so gives us, this is an array And as it uses so the library tal, this is an array of length 0 of root int candidate that is allocated from that context. And as it uses tal r function, we can count with tal count the length of that array, and we can also grow it. So this is cool to know. So this is that line. And now what we do is that we loop over that array. Yes, this is that. Okay, so we do that. Other allocation for the R, which is root info, and in the scanning. So we see what we do with that line is to take the value of the short channel ID, fee base, all those information that come from a list incoming and from the buffer and the T, which is the value of the incoming channel. We are doing that, and we set some value. So we set, for instance, the pub key here. Then we set the short channel ID, and we set other value that is not from R. And if everything works correctly, where is the candidates? Not candidates. It's not. I hope I'm not one lying to you, and two missing something. If I miss something, I will. Okay, so we will skip that that part. It's not that I'm lost, but there are many stuff. But okay, so what we do is that we set some field of no. Okay, so I prefer not to say I will stop looking for something that I'm not understanding right now. But anyway, so we create the candidates in that array, and those candidates are passed back if we not here. So those candidates, because root int candidates are calculated and they are passed in the function that was calling it. But root int candidates. So we are going to stop in a few minutes, but just we log another stuff, and this is here. In the loop, we see that we can that pattern. Blah, blah, blah. I want just this one. Hello. So we go up. We are in that loop on the array of the list incoming. If we are after her, that means that everything went okay, and we set some value in the R things. Let's just change that thing, and we can call it short channel ID, and we are in root int. Okay, and maybe we can do something like that. Okay, so this is how we can use type to string to print out the short channel ID. So how does it work? Log debug, as we've seen before, we have to pass it first argument. This is the log. This is the logger. This one is Lightning main logger. This is the format string, and we just call it root int short channel ID. So we are going to see it in the appear twice normally. Type to string. This is because we want to. This is a function that take that some type. So this is the first argument. Temporary context is a tile type. So for tile allocated. So this is just that we need some things to allocate. So this one is defined globally. So each time we need to allocate something that that is temporary, as it's not attached or any another things, we use it one. And I don't know when it is freed, but anyway, we look at that. This is for the memory allocation that is done like that. Then some string, some type. So we want to transform that type into a string, and then we pass the address of the type of the thing that we want to return. So in that case, we want for the root int, we want the short channel ID of that channel. So this is what we do. To do that, we use a function type to string, and we can just look at that one. So this is not a function, this is a macro, and this is what we pass it. So we've seen the context, the type, and the pointer, and all the type that can be printed with that function are in that printable type. So we have it here. So here, not ID, and right now we are using short channel ID. So if there is any of the type of those types that we want at some point to log or to put in the JSON response of a command, we can use that. We go back here. This is what we've added in the array, and now let's just compile it. And I hope I did not make small mistakes. Or huge, but as I just copy paste and explain what we were saying. So let's go back to our terminal. Again, to use that new compiled stuff, we need to stop, start again, and we generate another, the last invoice that we generate today. And now we go into the log. We look for root. I put an S at the end. That was not the same. But we see here we have the short channel ID. This is what we've added because we are looping into the array of those channels with written by list incoming, and we have the second one here. So I will go back to the note, and maybe Eduardo, you can tell me if I'm done, or if I was at the doing something and I lost myself and I don't know where to stop. But I think that I've covered what I wanted to cover today with you. Okay, cool. So if it's okay for you, it is for me too. I hope you enjoy that session on the Bolt invoices, and we will continue in the next session until we've seen all the part that I would like to understand in the source code. So see you next time.